Hi, welcome to question 10 of the Leaving Cert Ordinary Level 2024 Paper 2. As always, if you want a copy of the notes I'm working off, send an email to shanetry@gmail.com. Like and subscribe to get access to more playlists. So the first question here, part A, is marked as part 1, 2, and 3. It's a 10 marker. So in Wimbledon Tennis Tournament 2023, the fastest woman serve was Arina Sabalenka at 120 miles per hour. Okay, they give a source, whatever. Now, part one says use the conversion rate. 1 mile is equal to 1.61 kilometers to convert 121 miles to kilometers. Okay. Now, this should be pretty straightforward. Okay. We're given the direct conversion. Okay. So I'm writing that out again. So if 1 mile is equal to 1.61, 2 miles is twice that, 3 miles is three times that, 121 miles is 121 times that. Okay. I often present this as if you're trying to convert 1 mile to 121, you multiply the left. If you multiply by the left, you must multiply by the right. Okay, and that's a kind of formal way to just keep your conversions within algebra. Okay, you don't have people do it all sorts of ways. Now, do the maths of that. Okay, 121 miles is the same thing as 194.81 kilometers. So pretty straightforward. Okay. Now, part two says convert 1 hour to seconds. Now, 1 hour contains 60 minutes. Each minute contains 60 seconds. So it's 1 times 60 times 60, which is 3,600 seconds. Okay. Now, it's often one of these things, just make sure you don't overthink it or underthink it. It happened one year. The question was like how many weeks it was needed as part of the question, how many weeks in a year. And a lot of people went 48. They kind of went 12 months by 4 weeks is 48. But there are 52 weeks in a year. Okay, so sometimes we kind of are blasé with how we think we remember numbers. So just make sure to just give it a little bit of thought. Okay, and that's it. And the answer should make sense. Like this, 1 hour, 3,600 seconds. Yeah, that sounds about legit. Okay, so you must have probably done it the right way. Now, part three says use your answers to part A1 and A2 to convert 121 miles per hour to meters per second. Now, sometimes in this kind of situation, I'm actually just going to check the marking scheme as I'm talking. Writing the answers to something doesn't say that, or does it? It doesn't say it specifically that if you write the answers from part one and part two, in part three, you get the attempt. But, you know, it's always good to do it. Even if you think your answers to part A1 and part two were wrong or you couldn't figure them out, make up an answer. Okay, never leave a blank space. Okay. So we're going to do the conversions here. 121 miles, okay, is the same thing as 194 kilometers ish. We worked it out in part one. Okay. Now that's in kilometers, and I'm trying to convert to meters. So I need to remember that for each kilometer, there's 1,000 meters. So in 194.81 kilometers, there'll be 194,810 meters. Okay, so just there's 1,000 meters in a kilometer. Now we know from part two that there's 3,600 seconds in an hour. So how many meters per second is there? Well, our meters are on top, seconds are on bottom. Use the calculator. I got 54.113. The question says to round that to 2 decimal places, so the 3 here is what matters, and anything less than 4 or less, the number prior stays the same. And I got my answer of 54.11 meters per second. Okay, so that wasn't too bad, although it was trickier in part one and part two, in my opinion. Now, part B here is a 5 marker, and it says tennis balls are in the shape of a sphere. For professional tennis matches, tennis balls can be of slightly different sizes. The smallest size allowed has a radius of 3.27 centimeters. Then it says find the surface area of this tennis ball. Give your answer in centimeters squared, so it's an area, like they say, correct to 2 decimal places. Now, the surface area of a sphere formula, okay, it's not the same as the area of a circle, which is pi r squared, because it's a sphere, it's got like 3 dimensions. That formula is given to you in the maths tables. The surface area is 4 times pi times the radius squared. Now, the only number I actually need here is the radius, okay, which is 3.27. I was given that. Put that number into the formula, use the calculator. I got 134.37 centimeters squared, and I've rounded that already to 2 decimal places. So not the worst question, as long as you know there's a formula for it. For anything to do with shapes or trigonometry, just have those pages open, flick through it. You'll generally, the formula will be given to you, and that'll make the question much easier. Now, part C says the cross section of a tennis ball is shown in the diagram on the right. The ball is made up of an air-filled center and a rubber layer of uniform thickness. So if you imagine, if you've ever seen a tennis ball cut open, you have the outer circle, the inner circle, and that's made of rubber or whatever, and inside is air. It gives it the bounce. It says the external radius R1, so this bigger radius is 3.4 centimeters. The internal radius is 3.1. Now we may need this, we may not. The difference there is 0.3. Okay, now I don't actually think we do need it. It says then find the volume of the rubber layer. Give your answer in centimeters cubed, correct the 2 decimal places. Now, this could probably give a problem to some people and be trying to look for a formula that gives the area, it's much more straightforward than that. Find the area of the big circle. So volume is equal to pi r squared. Okay. Sorry, I just had to pause the video there because I realized I'm an absolute blithering idiot. And I had, in my own answer, typed up, I had put in the volume of a circle as the formula for area of a circle. It's completely off the wall. So there's the volume of a circle, okay, a sphere, whatever. And then I'm given for the bigger circle, the external radius, the radius is 3.4. I put that into the formula and I got 164.636. Now, no, I wouldn't have turned it from pi form just to avoid having to round it. An area rounding that affects the answer will have a penalty. I do the same thing for the internal, so the same formula, except the radius here now is 3.1. Okay, run that through the calculator, I get 124.78. Okay, 8. Then to get the internal volume, the volume of the rubber layer, I'm going to take those two numbers away. Okay, so the bigger external volume, take away the smaller internal volume. That difference is the volume of the rubber, and that's 39.85 centimeter cubed. Okay. Now, part D, part 1 and 2 are marked together. It says here, the diagram on the right shows the smallest closed cylindrical container that contains 3 identical tennis balls, arranged one directly on top of the other. The radius of each tennis ball is 3.4 centimeters. The height of the cylinder is h. Show that h is equal to 20.4 centimeters. Now, that's fairly straightforward in a way. Okay, if the radius is 3.4, that means there are 6 radiuses making up the height. Okay, so in a sense it's 3.4 plus 3.4 plus 3.4 plus 3.4 plus 3.4 plus 3.4, or 3.4 by 6. Okay, and that gives me an answer of 20.4 centimeters. Now, part 2 then says, hence calculate the volume of the cylinder. Now, the volume of the cylinder is given by a formula in the maths tables, pi r squared, so the area times the height. Okay, so the area of this and all of those little areas. Okay, so it's a pretty straightforward formula. The radius here is 3.4. We know that because the radius of the circle is the same all the way around. So if it's 3.4 this way, it's 3.4 that way. The height we just worked out to be 20.4, although we were told it, but we confirmed it. Put that into the formula, okay, and then put it to the calculator. They want this rounded to the nearest whole number, so I need to turn from pi form. And the 8 here is what matters. So the next number goes up by 1 to give 741 centimeters cubed. Now, the part 3 here, marked on so on, it's a 15 marker. Okay, the 3 tennis balls could also be arranged one directly on top of the other inside a closed rectangular box as shown below. Find the surface area of the smallest such rectangular box in centimeters squared. Okay, so we'll go straight on to the. That's actually pretty logical when you think about it. Like, if they fit into it, this has to be at least 20.4 centimeters long. We found that out, we proved it, we were told it. We also know that this is 3.4, so like this would have to be 6.8, would be the minimum it could be. Otherwise the tennis ball wouldn't fit. And on the other side, okay, if you can imagine this turning into a rectangular, it'd be 6.4 the other way because it's a circle, so the diameter is the same all the way around. And that's the answer. Okay, so let me just flick it up here. The smallest rectangular box would have those following dimensions. Now the area of a rectangle is length by width, but we have like 4 different parts to it. And I don't have that drawn. Or can I draw it? I'm a terrible drawer. Okay. So if I can imagine this in 3D, that's one height. That's one face of it or something. Okay. Then we have the length of it here, and then the face of it there. So we have this part and then this part coming in. So the length, okay, by the height will be the area of this, but there's 2 of them, so I've counted for that. Then maybe this shape on top, okay, and the one on the bottom, okay, and then here's, so there are 2 of them, okay, as long as I get the right numbers, this would be 20.4 by 6 by 8 by 2 of them. And then we have the ones coming in at the side, okay, that's 20.4 times 6.8, but there's a second one of them, and that's the total surface area. Okay, so I hope that makes sense. Now moving on to the actual answer. How do I do that? Okay, I'm putting the numbers in, and this is where things can get tricky. If you can always do this 3 separate calculations, just add them all together. I'm doing this one big bulk calculation. And then when I put them all through the calculator, I got 647.36 centimeters squared. It doesn't ask me to round it, so that's the answer. Right, that's been the last question of the 2024 paper 2 of the Leaving Cert Ordinary level. If you want access to these notes, just send me an email at shanetroy@gmail.com. Like and subscribe to get access to more playlists. Best of luck.